All right, so I'm going to start by doing example 10 on the notes on asymptotes. So this is a rational function. Now, hopefully you remember when I was talking about example 9, we had y equals 4 over x plus 3. And I referred to this as bottom heavy because the bottom has a degree of 1, x to the first, whereas the top doesn't have any x's, so it's a degree of 0. Now, that means the degree on the bottom is bigger, making that bottom heavy. However, the example that I'm looking at now, example 10, the bottom's not bigger, nor is the top. The degree of the top and the bottom are both the same. Now, this is a very special case that I'm going to talk more about in a couple of minutes to describe the shortcut. But first, I'm probably going to do the vertical asymptotes because those are typically pretty easy for most people to find. So I want to just spend a few minutes talking about how to find vertical asymptotes. Again, when I'm looking for discontinuities, what I'm going to look for is where the denominator of this fraction equals 0. Now, there is one warning about this question in particular, is that, again, this finds discontinuities. So it may be a vertical asymptote or it may be a removable discontinuity. Not as likely to be a jump, but it could be. In this case, it's probably going to be a removable discontinuity. And so I'm going to first figure out where it's discontinuous. I'm going to figure out where the denominator equals 0. And then I'm going to go from there, and you'll see what I do in a minute. So first and foremost, again, try to focus on that denominator. Where is x squared plus 2x minus 3 going to equal 0? So what I'm going to do is I'm going to factor that x squared plus 2x minus 3. It should factor into x plus 3 and x minus 1. Always double check yourself, make sure you did it right. X times x makes x squared. Positive 3x minus 1x makes 2x, and positive 3 times negative 1 makes negative 3. So that is factored correctly. So then we go x plus 3 equals 0 and x minus 1 equals 0. So x equals either positive 1 or negative 3. Now that I got that taken care of, these I know, again, are going to be discontinuities. The question that I'm left with, though, is it for sure a vertical asymptote? Because that's what I'm looking for here. So the way I'm going to just verify this very quickly is I'm going to check the numerator, too. If it has a common factor, as in if it's the same factor top and bottom, then it's a removable discontinuity because I can remove that common factor. And if it's still in the denominator after I remove any common factors, that's going to give me the hint of vertical asymptote. And I'll just, again, verify that in a little bit. So I'm going to try to factor this 2x squared plus 5x minus 3. One way you could do that is by doing the quadratic formula. That is kind of a foolproof way to do it. The other way that I'm going to do this is I'm going to do slide and divide. It's got a lot of other names, but they're all essentially the same thing. So what I'm going to do is I'm going to take this 2 out front, this leading coefficient, and I'm going to slide it to the end, and I'm going to multiply. So that's going to give me x squared plus 5x, and 2 times 3 gives me negative 6 there. Factor this like normal. So we're going to have x plus 6 times x minus 1. Again, just verify that very quickly. And so now that I've taken care of the slide part, in comes the divide part. Now, if you remember, I slid by the 2 in the beginning. So what I'm going to do now is I'm going to divide these numbers by 2 as well. So 6 divided by 2 gives me a positive 3. And x minus 1 over 2, well, that 1 over 2 doesn't really simplify like the 6 over 2 did. So I'm just going to take this denominator and I'm going to work it over here in front of this x. So it's going to be 2x minus 1. Again, always good idea to verify yourself. Make sure you did it correctly. So I'll just check. X times 2x makes 2x squared. Happy there. We've got 3 times 2x, which makes 6x. And negative 1 times x, which makes negative 1x. If I add 6x minus 1x, I get 5x. And then we'll check the last number. We're going to do positive 3 times negative 1, which gives me negative 3. So that checks out. So I'm going to put this back together. Let me grab a different color. So my numerator is x plus 3 times 2x minus 1 over x plus 3 and x minus 1. Hopefully you're noticing we've got this common factor up here at front, that x plus 3. I can remove that as a common factor. So that suggests to me that x equals -3 is not actually a vertical asymptote, but it is in fact a removable discontinuity. The way that I can check that, the way that I can be 100% sure that this is in fact true, is I can take that -3 and plug it in to the leftovers. So 2 times -3 minus 1 over -3 minus 1. Now that's going to give me a -7 in the top and a -4 in the bottom. Since that's a regular old plain answer, not anything special, then I'm sure that this is in fact a removable discontinuity. But that still leaves me with x equals 1. Now, this is a vertical asymptote. This is, in fact, the only vertical asymptote for this particular problem. And again, I can verify this a couple of different ways. Number one, I can just try to plug it back in up here into the remainder stuff. If I do that, I've got 2 times 1 minus 1 divided by 1 minus 1, which should give me 1 over 0. Now, again, whenever you get a number divided by 0, that's hinting to me that something infinite is happening, which in this case is a good idea. It's what we want. A vertical asymptote, again, has y values headed toward infinity, which is present here with that 1 over 0. Again, if you want to be 100% sure and you don't feel comfortable with this algebra stuff, you can always just check numerically. Try the limit as x approaches 1 from the left, and hopefully you'll get something that's infinite, either positive infinity or negative infinity. That's what we would hope for. If that doesn't come up with an infinite answer, then we should check the right side too. If it goes to positive infinity or negative infinity, then we're good. As long as one side goes to something infinity, we're good. It's going to be a vertical asymptote. Now that I've got that covered, I'm going to go ahead and talk about the horizontal asymptotes. Now, again, I mentioned before, this is a special case. It is not bottom heavy, and it is not top heavy. So what I'm going to do is I'm going to focus on the leading coefficients of the top and the bottom. So I'm going to come up here and I'm going to look at the x squared part. And the number that's with the x squared is a 2. That 2. And if I look in the bottom, the number with the x squared is actually a 1. So I'm going to write y equals, the number on top was 2, the number on bottom was 1, which just gives me an answer of 2. So right now, my shortcut says the answer is y equals 2. Now, that's all fine and dandy. That's a shortcut. But let's just verify this briefly just to make sure that I have the right idea, to make sure I'm doing the correct work. So remember, horizontal asymptotes, you are looking for the limit as x goes to either positive infinity or negative infinity to give you a nice numeric answer. Hopefully you remember that when I do limits at infinity, the probably easiest thing to do here would be to simply just do the complex fractions method. Divide everything by the degree, the highest x exponent. So I'm going to divide everything by x squared. So 2x squared divided by x squared plus 5x divided by x squared minus 3 over x squared divided by x squared over x squared plus 2x over x squared minus 3 over x squared. I am going to simplify this just ever so slightly to see what happens. X squareds cancel out, so we're left over with 2. I've got 1x that'll cancel out, which leaves me with 5 over x. The next one, nothing cancels out, so it's 3 over x squared. Bottom, x squared over x squared leaves me with a 1 left over. Again, one of those x's will cancel out, so we'll have 2 over x minus 3 over x squared. Key thing to remember here is, as you take the limit as x goes to positive infinity or negative infinity, anything with an x in the bottom turns into 0. So that's what I'm going to look for next, is turning anything with an x in the bottom into 0. So I'm going to have 2 plus 0 minus 0 over 1 plus 0 minus 0, which leaves me with 2 over 1, which is just 2. So that's a good way to verify that this is, in fact, the correct answer. Again, the other option is, if you're not feeling comfortable with the algebra stuff, to always check numerically. You can check x goes to positive infinity. You can plug in things like 10, 50, maybe 100, or even 500 and see where that goes. The thing is as you test these bigger and bigger numbers, your y values should be headed toward 2. The same thing will happen on this problem if you try negative infinity. I'll put just regular infinity. Check negative infinity. So if you tested some negative numbers, you would still get the same answer here. I guarantee it on this problem. So, again, just recapping, the vertical asymptote on this problem was x equals 1. The horizontal asymptote on this one was y equals 2. We also had the bonus idea of a removable discontinuity at x equals -3. I could even say the y coordinate was 7/4. So hopefully that helps with example number 10. I'll see you again in example number 11.